So we've got this question about kinetic energy, right? So again, remember the equation, kinetic energy, or K, is equal to 1/2 mv squared. Now we've got a car. Now you might say, Mr. Bergman, I don't see a mass. I'm not given the mass. But if you double something's kinetic energy, the masses, it's the same car, so the masses will be the same, right? And so if I double the kinetic energy, how did I solve this? If I said it's going to assume that your mass is 1 kilogram. So you could say this equals 1/2, and no cars weigh 1 kilogram, but it'll make our life easier. And we know that he's moving at 14 squared. That's his kinetic energy, right? And then you double that number. If you double that number, whatever this comes out to be, I don't know what 14 squared times 1/2 is, then you'll set that equal to, you'll double that number. So let's say it's, I did actually find it. It was 98. So I got 98. So that's, and then if I double 98, so I say, 2 times 98 equals 1/2 times mv squared. Again, the m we're going to assume is 1, and you can now solve for v. You will not get double the answer. It will not be double the answer. So keep that in mind, and that's how you'll solve it. And if you're asking the question by what factor is the car's kinetic energy, if your speed is doubled to 28, now again, we talked about this in the opening video, but just if, again, you're taking k of 28 and k of 14, find k28, find k14 where the velocity is 28 and 14, and then you'll divide these two, and then that's how you get the answer. But you can actually logically think this through, because if you're doubling the velocity, you're not changing 1/2, you're not changing the mass, and it's v squared, you could probably logically figure this out without any calculator work.